Hi, I'll be presenting SynTex, a collection of parametric audio texture datasets for conditional training of instrumental interfaces. What do we mean by parameterized sound sets? Well, each SynTex sound set is created by a different sound synthesis algorithm while varying the parameters it exposes as a control interface. The sounds generated, along with the parametric metadata, can then be used for training and testing neural network models. Sound sets are textures, complex sounds with potentially infinite stochastic variation for a given stationary parameterization. And I've just included a visual image for an analogy. So we can go over to the syntex.sonicthings.org site, and we'll see a list of sounds, each that contains a description, a bunch of parameters that are exposed for that particular sound texture, and some key features of the audio data set that's generated. So let's do that. And we'll get an idea of what we mean by textures and parameter variation. So you can see that I've got some basic amplitude modulation, frequency modulation. Here's the chirp sound that I was talking about. And all sounds can be auditioned with a few samples. So we can listen to a few samples of the chirps. And that's for a particular setting of irregularity and octave sweeping rate and all of that. Pop sound is a similar sort of sound, but noisier. Talk waddle involves two different kinds of sounds, a wood sound and a chime sound. Tapping is inspired by the McDermott and Simoncelli tapping sound. Pistons is kind of an 8-cylinder engine sound. Can vary with rate and irregularity as well. And there's other sounds, schwa oscillator, mosquito sounds, wind chimes, peepers, etc. When you hit the download button, what you get actually is an algorithm for generating the data set. You don't get the data set itself. When you install, the data set is created locally on your own machine. It grid samples the parameters that the algorithm exposes to create all your files in the dataset. And a configuration file allows you to set certain parameters for your dataset. Sample rates, sound duration, random seeds for the random number generators that the algorithm uses, and which parameters are grid sampled and how densely they're sampled. So to put this in the context of other data sets, Escape 50, Urban 8K, and Audio Set are all general purpose audio, very noisy, but they're oriented for classification. Sounds are not systematically varied according to some parameterization. NSynth, on the other hand, is a set that includes parametric variation for conditioning, training a neural network, but it's instrument sounds. They're almost all pitched. SynTex essentially puts these ideas together and has systematic parameter variation for noisy, rich, more environmental-like sounds. So what's the use cases for these? Well, in general, you could do data augmentation for classification, develop models with proven capability before getting all your messy real-world data together and labeled, or quantifying where and how models fail by systematically varying parameters for timescale, for example. But SynTex was specifically designed for training generative sound models and their interfaces. So SynTex is good because you can generate unlimited data with robustly labeled conditional values. It provides you with ground truth for hidden factors in sound generation that would be impossible to extract from real sounds, like, for example, the standard deviation of center frequency variation, for example. More interesting perhaps is the way that systematically varying data sets can be used to combine radically different sounds into one generative model, for example, using a GAN that generates novel sounds in between the sounds in your data set. And you can steer the way the GAN learns to organize its latent space by using carefully chosen parameter variations of your SynTex data sets that you use for training. So enough said, but if you want to see how we use these sounds for training generative models, please check out our Sound Model Factory paper that we just presented at EVO MuseArt. And with that, I'll say thank you very much.